Well, here we are, geometry, starting chapter 10. So 10.1, areas of parallelograms and triangles. You're going to have a boatload of formulas, and you can certainly find the formula sheet and use it as a reference, but I need you to memorize these. You guys need to know these. These are basic formulas that you'll need to know. Trying to think of what's coming next here. Trapezoids and rhombuses and kites. So at least these basic formulas should be memorized. Once you get into the three-dimensional ones, it's okay. But these should be memorized. So here we are. We got the rectangle, and notice I put on what makes it a rectangle via the definition. Okay, and remember on the back of the whiteboard we have all of those figures and all the different things about figures, so you could certainly look on the back of the whiteboard in class if you wanted to be reminded, or you have the sheet actually. Area of a rectangle, A is for area, B is for a base, that's a side, H is for the height. Base and height are always perpendicular. Base is always perpendicular to height. I would write that down. Always. Always, always. It's never, ever not. So, and then a parallelogram is also base times height, but again, they're always perpendicular. So since a parallelogram, the only requirement is that these opposite sides are parallel. We don't necessarily have the perpendicular automatically given to us, so we have to find a spot where that height is perpendicular to one of the sides. So even if that height falls outside of it, it's still the height of the parallelogram. This is the base, but the height doesn't have to be a side. It just has to be perpendicular to that base. Okay, here it doesn't even touch it, but it's still perpendicular. When you're doing a rectangle, it will be a side, both sides. And then a triangle is half of the base and the height. So again, if it's a right triangle, which I'll draw right here, if it's a right triangle, then they are perpendicular. But if it's any other type of a triangle, the base is always a side, but again, the height isn't a side. The base is a side, the height is not a side. Okay, you could also think of this as base times height divided by 2, because these are certainly the same. All right, so let's practice. Find the area of the parallelogram. So go ahead and do that. And we'll make sure that you were listening and we're figuring out which things here you would use, because there's more things than you need. So which two are the ones that you would use? For your work, for your homework, make sure you always put your formula first. There's so many formulas. That's the first thing, is to make sure you're using the right formula. Okay, so base times height. Base is always a side. So it's either going to be this or this for the side. Well, it depends. You need a height that's perpendicular to that. So when I see this other thing, this is my perpendicular on here. So this is going to be my height because it's perpendicular to this as my base. There's nothing perpendicular to this. So this one I'm not going to use. So area equals 2 times 3.5 centimeters. We do not need, that's also centimeters. We do not need a calculator for that. And it's 7 centimeters squared. Remember, whenever you deal with area, you always have the squared. When you have a length, and then you don't. When you have a volume, then it's cubed. All right, so a parallelogram has sides of 15 and 18. The height corresponding to the 15 centimeter base is 9. What is the height corresponding to the 18 centimeter base? Oh, tricky, tricky, tricky. Let's draw ourselves a parallelogram so we can get a better handle on what's happening. It says the sides are 15 and 18, so I'm just going to put the 15 here and the 18 here. That's a small one. And it's saying that the the height corresponding to the 15 is 9. So that means coming off of the 15 perpendicular, that is 9. Now its question is, well, what's the height coming off of the 18? The one that's going to be perpendicular there. It's not the same. No, no, no. But, again, start with your formula. Area of a parallelogram is base times height. So can you figure out the area of this parallelogram? Yes. Which two would you use? These two, right? The base and the height that is touching it, or perpendicular to it, I should say. So that would be 15 times 9. 135 centimeters squared. Okay, it didn't ask you for the height, for the area though, but that's going to help me because this area doesn't change depending on which pair I use, right? So I use these two to figure out the area. But now that I know the area, can't I use that to figure out this and use this as my base? So sometimes you're using a different combination. You're like, okay, well, I can get this area, and now I can restart the formula, and I have the area. That didn't change. But I can use this as my base, and now figure out the height. Divide by 18. Oh, what is that? Should be 7.5 centimeters. And again, it's not squared because the height is just a one dimension. So it's centimeters. All right, let's figure this out. What is the area of the triangle? Well, area of the triangle, start with your formula. Always on your homework, write your formula first. Put your numbers in second, answer third. Show your work. We got an issue here. Do you guys see the issue? Yeah, we got 2 units going on here. We can't have that. What's going to be easiest? I think it's easiest if we take the feet and change them to inches. So 1 foot here would be what? 12 inches. And we got 1 foot 1 inch there. So how many inches would that be? The 12 plus the 1, this whole thing is going to be 13 inches. All right, we can pop it in now. So area equals 1/2. What is the base and what is the height? Well, it's a right triangle. Remember how I said in the right triangle, the base and the height are the two that are perpendicular. They are the actual two sides. So it's going to be the 5 and the 12. They're kind of interchangeable. It does. I'll put the. It's not going to matter because of commutative property. It doesn't matter the order you multiply them. But you can do this in your head. Don't start by doing 1/2 of 5, guys. I mean, you can, but it gives you a decimal. Do the 1/2 of the 12, because a commutator you can do it in any order. What's 1/2 of 12? 6 times 5, 30 inches. And it is area, so it is squared. All right, the last one we have, and then you're going to have some work time probably today, is the area of this figure. So when you have sometimes figures are multiple different figures, right? So I've got this. I got the area of a triangle on the top. And I have the area of, what is that figure? I got a square, right? It tells you by the markings. I got 4 equal sides and 4 right angles. So area of a square, which we don't even have up there, but you know it. What is area of a square? It's S squared. Let's add it. Okay. Back down here. Area of a square. Side is 6. So area of that square is 6 to the 2nd power. And the area of the square is 36 inches squared. So we got that part. 36 inches squared. But I need to get this area of the triangle too. because then I'll need to add the two together. So triangle's 1/2 base times height. Well, this can be the height, right? But the base has to be the side perpendicular, so I need this side. So I have the height is 8. Can you guys tell me what this side is? Of course you can. These are all the same. So it's 6. So let's do that in our head. Half of 6 is 3 times 8 is 24 inches squared. The area of this figure is the area of the triangle plus the square. So we have 24 plus 36, which is equal to 60 inches squared as our final answer. So, I'm going to back up in case you missed something on the sheet. I guess I can't really fit it all, but all right, we'll see you tomorrow.